Well, I really hope deep down in my heart that you won't be offended if I choose to skip 3.1 because it's relatively easy, right? So let's give our special attention to 3.2. So here they say to us in a linear number pattern, the first term is 2x plus 11, the second term is 2, and the fourth term is 2x minus 4. So we don't know what is the third term. Now they say for 5 marks, please calculate the value of x. Well, the first thing we need to do, of course, is to write down our pattern, because one thing we know about a linear pattern is that it's characterized by a constant difference, right? So since we don't know what is term number 3, we can choose to call it T3. But of course, if you like, you can let it to be y so that you work with x and y. And then, of course, our term number 4 is just going to be that. And the pattern goes all the way to infinity. So now we come and find the differences. So this is how it's going to look like. Right. And then if you say 2 minus 2x plus 11, well, you simply get negative 2x minus 9. Remember that you had to open a bracket and distribute the negative sign. And then if you say T3 minus 2, well, it's just going to be T3 minus 2. And here you get 2x minus 4 minus T3, right? But then here we can see that it becomes difficult to solve for x because we don't know what is the value of T3, right? So let's begin by finding the value of T3. But the question is, how do we do that? Well, since a linear number pattern has a constant difference, it means quite simply, this negative 2x minus 9 is exactly equal to T3 minus 2, which in turn is exactly equal to 2x minus 4 minus T3, all right? Okay, fine. So we can just focus on the ones with a T and solve for T3. Well, since they're equal to each other, we might as well equate them, right? So this is what we say. Okay, fine. And then we take this one to the left-hand side. It becomes positive, and 1 plus 1 will become 2, right? Then we take this 2 to the right. It becomes positive. Negative 4 plus 2, it's negative 2. So here we have 2x minus 2. And then we divide throughout by 2. So it means every time you see T3, you actually see x minus 1. Okay, fine. So now we know the value of T3, at least in terms of x. So it means we can actually come and say we have 2x plus 11, we have 2, we have x minus 1, and we have 2x minus 4, all right? And then we find our differences again, because now our differences won't be in terms of t, but rather in terms of x. Okay, fine. Well, here we still have negative 2x minus 9. Now what about here? Well, we have x minus 1 minus 2. So we get x minus 3. Now what about if you say 2x minus 4 minus x minus 1? Well, this is how you're supposed to say it, right? And of course, you distribute the negative sign. And this is what you will get, okay? Then 2 minus 1 is 1. Negative 4 plus 1, it's negative 3. So it means here you have your x minus 3. Okay, that's fine. But of course, you still use the fact that in a linear pattern, the constant difference is actually constant, right? So it means you're simply going to take negative 2x minus 9 and set it equal to x minus 3. Then take the negative 1 to the right, so it becomes positive, and take this negative 1 to the left, so it becomes positive as well. So on the right-hand side, you have 3x. On the left-hand side, you have negative 9 plus 3, which is negative 6. And dividing both sides by 3, you find that the value of x will simply be positive. In fact, negative 2, sorry. But don't just accept the value of x that you get. Test it and see if it actually works, right? So how would you test it? Well, of course, you substitute it there as well as there. So if you substitute it here, what do you get? Well, negative 2 minus 3, you get negative 5. Negative 2 times negative 2, you simply get positive 4. And positive 4 minus 9, well, you get a nice and beautiful negative 9. So this is how you could have done it, and you should be happy.